let's get straight to the point. Hello and welcome to Underdog Physics. Today we'll be looking at gravitational potential energy, also known as GPE. When we lift objects up, we use energy to do so. By this I mean we transfer energy to the object. The energy transferred to the object is given by this equation. Gravitational potential energy, or GPE, is equal to the mass of the object times gravitational field strength times the height that we've lifted it. Lowercase g, or gravitational field strength, on the surface of the Earth is about 9.81 newtons per kilogram. And since we don't tend to lift objects very high compared to the radius of the planet, we can assume that the gravitational field strength is constant, by which I mean it's still 9.81 newtons per kilogram everywhere. Fun fact, our planet is not a perfect sphere. It's a bit squashed at the top and bottom ends. This means that on the equator, the gravitational field strength is a bit less than if you're stood at the poles. In fact, a quick calculation using some data from Britannica shows that the gravitational field strength on the equator is about 9.79 newtons per kilogram, but at its poles, the gravitational field strength is 9.86 newtons per kilogram. Crazy! Then again, that's less than a 1% difference. And remember that if we're stood on the equator, we're about 22.4 kilometers further away from the center of the planet than if we were stood on the poles of the planet. So basically, when I lift my tangerine... So when I lift this non-specific piece of fruit by about 2 meters or so, there's no difference in the gravitational field strength. Whew! In short, anywhere on the planet, we can assume that the gravitational field strength is 9.81 newtons per kilogram, so long as we're only lifting our objects by up to a couple of kilometers. Though I'm not quite sure why anyone would be lifting objects more than that on a regular basis. Maybe pilots, but they've got other things to worry about instead of gravitational field strength, I guess. But wait, there's more! Gravitational potential energy is actually change in gravitational potential energy. By lifting the tangerine half a meter off the coffee table, it has bloop, 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 0.348 joules more GPE than when it was on the coffee table. And when it was on the coffee table, it had bloop, 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 0.279 joules more GPE than when it was on the floor. And when it was on the floor, it had 2.16 joules more GPE than when it was on the coffee table downstairs. And on that coffee table, the tangerine had 0.279 joules more GPE than when it was on the floor downstairs. And when it was on the floor downstairs, it had 2.16 joules more GPE than when it was on the third suspiciously identical coffee table in the basement, which is 0.279 joules more GPE than it had when it was on the floor of the basement, which is 2.16 joules more GPE than it had when it was on the questionable fourth identical coffee table in the sub-basement. And when it was there, it had 0.279. Now I'm just being silly. Change in GPE of an object is equal to the object's mass multiplied by the gravitational field strength that it's in, multiplied by the height that it's lifted by. And remember, gravitational potential energy is measured in joules, and if we want to calculate it, be sure to put your mass in kilograms, your gravitational field strength in newtons per kilogram, and your change in height in meters. Thank you very much for watching. I hope you found this useful. Please do feel free to suggest videos you'd like to see in the comments below, and subscribe if you haven't already. Gravitational field strength is actually change in gravitational field. What am I talking about?